Okay, this one's crazy. I don't know why it only has 3 lines when this one seems more bizarre. So what color should we make Mercury? You got this Mercury chilling out in this tube, okay? Now we know if I pour something in a tube, we're going to have a equal line where the Mercury's just chilling. We could call that 0.1. When I start to pour water, I should have made water blue. Unbelievable. When I start pouring water on here, this mercury is going to go down a little bit, or some sort of other. The water, I'm struggling. The water is going to come pouring in. It's going to apply a little bit of pressure on this, and this mercury is going to go down to this new level, and the water is going to push it away. So if we call this new level 2, we could say that's a height. Well, because these liquids are compressible, are uncompressible, I need to go to bed. This mercury is going to go up this height over here, this same H that the water pushes it down, and the water is probably going to sit on top. Mercury is super dense. So when we're done, this water is going to be pushing, it's going to be probably higher than this mercury. But whatever this height is, if it goes down 1, it has to go up 1. Now, if I continue this line through here, and this is an H, and this is an H, isn't this distance from here to here really 2H? This one's pushing it down, this has to go up. So from the bottom of this bad boy to the top of there is really 2H. Alright, that's important with this. Alright, I heard all the griping, so I got a better picture. This water pushes it down a certain distance. It's going to go up a distance, but it's kind of stacking on itself. So this distance over here, let me get a different color. An H plus an H is really 2H. Is it not? Please tell me it is. It is. Alright, let's see if that works here. Let's look at the 0.1, the pressure at 0.1. It's going to be the atmospheric pressure pushing down on the water. I kind of moved my 0.1. Let's go down here. This is my 0.1. Sorry, I'm a terrible drawer. Leave me alone. At 0.1, it's the atmospheric pressure plus the density of water. I'll put a W. Gravity and the depth of the water. Okay? Let's look at 0.2, which is over here. The pressure at 0.2 equals the atmospheric pressure pushing down on that bad boy plus the density of mercury. Is it mercury? Hg plus multiplied by gravity and the depth of the mercury at that point. Now, we just said, I'm going to rewrite that. You know what? No, I'm not. The depth of the mercury is really 2D. I called it H over here, but it's really 2D, H and D, same thing. Okay? Now, the pressure at 1 equals the pressure at 2. How do we know that? Because it's that equal line thing we talked about earlier. Equal line, equal pressure. So let's replace 1 with what we have up here. Atmospheric plus density of water times gravity times the depth of that water equals 2, which is going to be the atmospheric pressure plus the density of mercury times gravity times 2 depths of the mercury. And the D in the D okay. Alright, what do we got to get all alone over here? Well, isn't the atmospheric pressure on both sides the same? Bye-bye. Isn't gravity the same on both sides? Bye-bye. The density of water is not the same. No. The depth of that water is not the same. The density of mercury, we can figure that out. It will get it somewhere. And then we've got this 2D. So I have to solve for D, do I not? So this is all gone, right? We need to get, I did not mean to get rid of that. We need to get this D all by itself. So let's divide both sides. So I have the density of water. I'm going to get that density of mercury out of there. So that's gone. I moved it to the other side. Now how do I get that D out of there? I got to divide that 2 out of there. And that should give me the depth. Whoops, there should be a G there. Of the mercury. I need some more room. Alright, this is taking forever. This is horrible. Density of water, 1,000 kg meters cubed. 2 times the density of mercury. Look that bad boy up. It's 13,600 kg m cubed. Oh, we forgot a density of water over here. Or not density, depth. So I need a depth of water. Oh my god, this one's a train wreck. This depth of water I just forgot. I don't want to restart it. I'm 8 minutes in. Please don't make me restart it. And they said it's 10 centimeters, which is 0.10 meters. Wow. I need to call it a night here, do I not? And that will equal the depth of the mercury. Throw that all in your calculator. You should get 3... not 3. I'm going too fast. Put that in your calculator. You're going to get 0.00367 meters. But you probably want to put that in millimeters. So let's move it over 3. 1, 2, 3. 3.67 millimeters. Sorry about that. But all I forgot was one thing. You can help me out and just... Right? Does that make sense? Hopefully. Okay. Bye-bye.